Hey y'all, welcome to lesson 1 for the week of May 4th. Today we are starting a new unit. It's our last unit of the school year and it covers acids and bases. So for today's lesson we're going to keep it really simple and we're going to learn how to identify the most common kinds of acids and bases, and we will learn about the definitions of acids and bases. Let's get started. First, we're going to ask that you recognize the most common class of acids. It's pretty easy. Their formulas start with hydrogen, just like these examples. Okay, so we have HCl for hydrochloric acid, HNO3, H2SO4. Okay, so really any examples we give you that start with hydrogen, you would say that's an acidic compound. And that even includes H2O. Water does behave as an acid in certain situations. Okay? Now there are other things that behave acidically, okay? So as you learn more about chemistry, you'll realize that there are a lot of other things that are acidic that don't necessarily start with hydrogen, okay? But that's more sophisticated and we're not going to address those in a chemistry class in high school, okay? For bases, again, it's pretty straightforward. We're going to have a metal, so potassium, calcium, nickel, aluminum. We're talking about the elements on the left-hand side of the periodic table, and those metals will always be bonded to a hydroxide ion. Okay, that's that OH ion. So potassium hydroxide like this. Now these bases should look very familiar. Okay, we learned how to name and write formulas for these back in Unit 3, so way back in first semester when we learned about ionic compounds. Okay, because we've got a metal, positive cation, non-metal, negative anion. We're not going to have you naming and writing formulas during this distance learning, but you would need to recognize that because these end in OH hydroxide, they're going to be basic compounds. Alright, now this is important. There are absolutely other things that are basic that don't end in OH. Okay? We're going to talk about those here at the end of this lesson, but I did want you to get the chance to see this. Okay? Now, we've known about acids and bases way back to like ancient Greek time. Okay? People were very much aware that there are different types of chemicals that behave in different ways. Okay? And they started trying to define what are acids and what are bases. For us, when it comes to recognizing acids and bases, you will recognize an acid that starts with hydrogen, a base that ends with hydroxide. Okay? And really what we're looking at is anything that puts H plus when it dissolves into a solution, and anything that puts OH minus when it dissolves into a solution. Now when it comes to defining things, it gets a little harder to set like a set of rules that if you fall in this box, you're acidic. So the first time that we have where someone was trying to set a definition for acid and base was this scientist down here, ORHS. Okay? And he, just like we've talked about so far, defined an acid as something that contains hydrogen and will dissociate in water to let go of that hydrogen in the form of an ion. So H plus, or with H2O, right? If you add that H plus to H2O, you get H3O with a plus charge. Okay? Now that sounds messy, but that just means an acid is a chemical that already has hydrogen that can let it go when it dissolves in the form of an ion. Okay? So an example of that right here, you've got hydrochloric acid. So HCl, when you mix it with water, it will let go of its H plus and its Cl minus. Okay? Now where's the H plus? It just got stuck on the H2O. Okay? So that's why Arrhenius says that this chemical would be considered an acid. It starts with an H and it lets it go. For bases, he defined a base as something that already has hydroxide, and when you mix it with water, will release that hydroxide, just like this example down here. So according to the Arrhenius definition, sodium hydroxide is a base because when you mix it with water, it lets go of a cation, and then specifically it releases this OH hydroxide ion. Okay? Now it's a great definition, but it is not a very broad definition. Okay? So this is some of the issues with it. So according to the Arrhenius definition, only compounds that already have hydroxide in them are bases. But that's demonstrably false. Okay, so ammonia, NH3, does not have OH in it, but it is absolutely a base. And you've got some in your house, odds are. You've either got ammonia under your kitchen sink, or Windex is primarily ammonia, and we can prove that it acts basic. So how can this be a base if it doesn't have OH in it? So I'm going to show you a quick video that helps to explain that.
Than you thought it was. In 1923, two guys simultaneously defined acids and bases in the exact same way. Bronsted and Lowry defined them. They didn't classify them by how they acted or what they tasted like or even what they were made of. They defined them. And this was an impressive feat because a huge class of molecules, to some extent or another, act as acids and bases. So to come up with a definition that fit all of them, that was not so simple. Bronsted and Lowry defined an acid as being anything that donates a proton and a base as being anything that accepts a proton. And when we say proton, what we're talking about here is a hydrogen atom without it.
Okay, so what he was trying to explain is these two scientists, Bronsted and Lowry. So they were able to provide a more complete list of which compounds are really acidic or basic. All right? So what you need to memorize about their definition is just this. An acid is a substance that can donate H plus in a solution. Okay? An H plus, a hydrogen atom without its electron, is just a proton. Okay? So we say that acids, according to the Bronsted-Lowry definition, are proton donors. They give away H plus. Even if they didn't have the H plus to start with, they can still increase H plus. Bases then. Bases are the opposite. They're any substance that can accept a proton, an H plus ion in a solution. So we call those proton acceptors. Now this image down here at the bottom is the one I really need you to be taking a look at. Okay, and I think, yes, I do have it right here. So ammonia, we said, is definitely a base, even though it doesn't have OH in it. And it's because when you mix ammonia with water, ammonia will accept a proton from water. That means it will rip away an H plus, and that leaves OH minus. So H2O. If I take away one of the H's, I'm left with just H1O. Okay? So ammonia mixes with water to turn into ammonium, and it creates hydroxide. Even though ammonia didn't have hydroxide to start with, it can still create that basic solution. Now that seems way weird and confusing. Let me break it down. All you need to know about the last 6 minutes of this lesson are going to be written right here in this table. So let's take a look at it together. All right, this is what I need you to have memorized, or to use as notes on your quiz. I don't really care at this point. Arrhenius definition of acid and base. Something that already contains and then releases H plus, hydrogen. Base, something that already has and releases hydroxide, OH. Okay? So the Arrhenius definition, I had this to start with and I let it go at the end. For bases, I had OH to start with and I let it go at the end. Okay? Bronsted-Lowry is a little bit more specific, and we just need these words. According to Bronsted-Lowry, an acid is a proton donor, which is the same as saying it gives away H plus. All right. And according to Bronsted-Lowry, a base is a proton acceptor. Don't get them backwards. Okay, it's really common. But this table is what you need to have memorized in order to be successful on the homework check and the end of the week quiz. It seems like a lot that we did today, but it's really not that much. Okay? Pause this if you need it. I want to look at the examples on the next page of notes with you real quick before I turn you loose. It's a shorter lesson. So again, here's our example questions. And if you have that table in front of you, you should be able to answer these ones. So the Arrhenius definition stated that acids produce blank ions. Those would be hydrogen ions. Okay? Because acids have and then release H plus. And something is a base if it has and then releases the hydroxide ion, OH minus. Bronsted-Lowry defined bases as blank acceptors. That would be proton acceptors. Okay? And acids as proton donors. Okay, so not electrons. This has nothing to do with electrons. All right, that's it. Now, looking at this, being able to identify common acids and bases, right? It comes down to the hydrogen or the hydroxide. So we're going to go through and circle all of the acids and underline any bases. So this one starts with H. I'm going to call that an acid. H2CO3, this would be carbonic acid. Okay, phosphoric acid. KOH, that's potassium hydroxide. And hydroxide means that this would be a base. HF, that's hydrofluoric acid, starts with a hydrogen. Base, so sulfuric acid. Base, OH base, HNO3 acid. Okay, so I circled everything that starts with hydrogen, and I'm going to underline everything that ends in OH as being a base. Okay, it's as straightforward as that. Alright, make sure you're watching the video tutorial for today's homework check if you think you need help, and good luck.